Pluto, a faraway and jumbling, more modest planet, was once a striking individual from our planetary group's planetary family. Anyway, later momentous explanations by driving astrophysicists Neil deGrasse Tyson and Michio Kaku carried Pluto back into the spotlight with a shocking disclosure. They recommend that this cold world is on a potential crash course with Neptune. Yet, how is it that this could happen? In addition, what may be the results of such a huge occasion? Are we seeing an entrancing grandiose peculiarity, or is there more to this looming divine debacle? Go along with us as we investigate the potential results of a Pluto-Neptune crash. Pluto, a previous planet downgraded to a bantam planet because of its flighty circle, stays a subject of revenue and concentrate in mainstream researchers. As per late expectations by driving specialists, Pluto's direction is alarmingly near Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising worries about a potentially horrendous crash between these two heavenly bodies, which could represent a huge danger to Earth. Yet, how is such an occasion even conceivable? Pluto's excursion around the Sun is not normal for some other planet in our planetary group. It requires a stunning 248 years to finish a solitary circle. This really intends that, since its disclosure in 1930, it hasn't even finished one full revolution. Anyway, the interest doesn't stop there. Pluto's way is set apart by its exceptionally capricious shape, veering off extraordinarily from the almost roundabout circles of the significant planets. What makes Pluto's circle considerably more surprising is its tendency, shifted at 17 degrees to the ecliptic plane. The way Pluto follows is undeniably more limit contrasted with different planets. This slant and unconventionality add layers of eccentricism to its orbital example. One of the most captivating parts of Pluto's circle is its communication with Neptune's. For roughly 20 years in each circle, Pluto truly draws nearer to the Sun than Neptune, opposing what we could anticipate from their situations in the nearby planet group. This brings up the lasting issue: why hasn't Pluto crashed into Neptune? The response lies in the gravitational impacts of different planets. The investigation of Pluto's circle began not long after its revelation. At first, space experts attempted to grasp its uncommon way. Dissimilar to different planets whose circles lie moderately near the ecliptic plane, Pluto's circle stood apart with its lofty tendency and emphasized shape. The secret developed with the acknowledgement that Pluto's circle truly does, truth be told, cross Neptune's. The security of Pluto's circle in the midst of these intricacies is proof of the complexities of divine mechanics. The three-body issue in space includes understanding how three items, like Pluto, Neptune, and the Sun, move and impact each other with their gravity. It's like attempting to foresee where they will go in view of where they start and how they pull on one another. For Pluto's situation, this issue shows how its circle, Neptune's circle, and the Sun's gravity collaborate in a mind-boggling manner. Terms like asymptotic libration and mutual libration, alongside the VSK swaying, are essential for this riddle. As per astrophysicists, what keeps all planets in their circles is a kind of libration. For Pluto and Neptune, this term implies that, at whatever point Pluto crosses Neptune's circle, its position is generally no less than 90 degrees away from Neptune. This spatial partition is vital in keeping their circles from impacting. Mainstream libration, then again, alludes to the upward development of a divine body in its circle. For Pluto, this implies that when it comes nearest to Neptune or some other monster planet, it is situated far over their orbital plane, giving an extra layer of assurance from potential crashes. One more basic figure in this situation is the VSK swaying. This peculiarity, named after three researchers, V.A. Vashofak, A.I. So, and K.A. Verov, makes sense of how three heavenly items like Pluto, Neptune, and the Sun connect gravitationally. This gravitational pulling influences their developments, and for Pluto's situation, VSK assists us with understanding the reason why its circle close to the Sun is so remarkable. Regardless of the obvious confusion, this swaying keeps up with Pluto's circle in a steady state. Endlessly understanding its circle is pivotal, as it gives us a more clear image of the unique idea of the nearby planet group. The instance of Pluto delineates how even the most apparently unsteady circles can accomplish a condition of harmony through the mind-boggling transaction of gravitational powers and orbital mechanics. It additionally features the significance of constant perception and investigation of these peculiarities to more readily comprehend our spot in the universe. Investigating the profundities of room frequently drives us to new experiences and disclosures about the multifaceted dance of divine bodies. The chance of a Pluto-Neptune impact might sound disturbing, yet the components that forestall such an occasion likewise highlight the accuracy of orbital mechanics. The multifaceted gravitational connections between divine bodies in our planetary group have made a fragile equilibrium sharpened over billions of years. This equilibrium takes into consideration the steadiness of Pluto and Neptune, as well as the innumerable different articles that populate the Kuiper belt, where Pluto dwells. Understanding these elements assists researchers with refining their insight into how the nearby planet group framed and advanced. The Kuiper belt, a district of frosty items past Neptune, is home to many bantam planets and different remainders of the early planetary group. Pluto's conduct offers important hints about the set of experiences and present status of this far-off locale. Moreover, concentrating on the interesting qualities of Pluto's circle improves our capacity to foresee possible future shifts in its course. While current models propose a steady connection among Pluto and Neptune, enormous powers like passing stars, interstellar articles, or disturbances from other divine bodies could modify this equilibrium over the long haul. This examination additionally has suggestions past our planetary group. Exoplanetary frameworks, which comprise of planets circling stars other than the Sun, frequently highlight tumultuous and unusual orbital examples. By understanding the complex gravitational cooperations in our own framework, researchers can apply these standards to study and foresee the way of behaving of exoplanets and their potential for facilitating life. On account of Pluto and Neptune, researchers keep on checking their circles with cutting-edge telescopes and PC reenactments. These devices take into account exceptionally exact displaying of divine elements, empowering analysts to expect changes far into the future. Noticing such peculiarities likewise gives insight into the strength of our planetary group's design and features the amazing intricacy of the universe. Pluto, once excused as a mere bantam planet, has demonstrated to be a mother lode of logical revelation. From its novel circle and geological highlights to its potential crash course with Neptune, Pluto stays a demonstration of the consistently advancing nature of galactic examination. Whether it's an issue of concentrating on its orbital dependability or disentangling the secrets of its frigid surface, Pluto keeps on enthralling researchers and stargazers the same. As we adventure further into the universe, the narrative of Pluto fills in as a sign of the sensitive exchange of powers that administer our nearby planet group. It features the significance of investigation and disclosure, motivating us to keep trying the impossible, looking for replies to the universe's most significant inquiries. Confronting the capricious nature of heavenly bodies, Pluto's circle is an ideal outline of this flightiness. The possibility of orbital chaos, which implies the tricky reliance of a heavenly body's circle on its hidden conditions, is doubtlessly shown on account of Pluto. This infers that even slight assortments in the bantam planet situation or speed can significantly change its long-term circle. Using automatic insights has been marvelously helpful for exploration to comprehend how Pluto moves in space. These recreations utilize convoluted math to imitate how Pluto, close by other space objects like Neptune, pulls on each other. By changing little subtleties in the reproductions, cosmologists can perceive what even tiny changes can have a massive impact on where Pluto winds up. By and by, notwithstanding this disorder, Pluto's circle stays stable for broad periods, billions of years. This implies Pluto's excursion around the Sun has a sort of request to it, despite the fact that it appears to be sporadic at first. Foreseeing critical occasions, particularly those including tumultuous circles like Pluto's, presents colossal difficulties. The inborn flightiness of these frameworks implies that long-term forecasts are frequently laden with vulnerabilities. While numerical reenactments give an incredible asset for understanding and foreseeing the future way of behaving of divine bodies, they additionally feature the restrictions of our prescient capacities. These models vigorously depend on the exactness of starting circumstances and the intricacy of the associations they mimic. Any slight mistake or mutilation can prompt boundlessly various outcomes, making exact expectations an overwhelming undertaking. Moreover, the turbulent idea of heavenly circles like Pluto's helps us to remember the steadily developing and dynamic universe. While we have taken extraordinary steps in understanding space, the instance of Pluto reminds us that our insight into the universe stays restricted. Understanding the gravitational impacts of Goliath planets on Pluto's circle offers significant bits of knowledge into the more extensive elements of the planetary group. It demonstrates the way that the presence and position of every planet can have sweeping impacts, influencing the security and direction of different bodies inside the framework. Thus, while a Pluto-Neptune crash stays a hypothetical situation, its very thought supports our obligation to investigate, comprehend, and plan for the immense secrets that lie past our reality. The investigation of Pluto's flighty orbit reveals the dynamic complexity of our cosmic environment. Despite being downgraded to a dwarf planet, Pluto remains a crucial subject of scientific inquiry. Its eccentric orbit, tilted at an angle of 17 degrees relative to the ecliptic plane, sets it apart from the major planets, challenging traditional planetary definitions and deepening our understanding of celestial mechanics. One of the most remarkable features of Pluto's orbit is its resonance with Neptune. This orbital resonance ensures that despite their intersecting paths, Pluto and Neptune will never collide. Every time Pluto crosses Neptune's orbit, its position is carefully timed so that the two bodies are always at a safe distance from each other. This gravitational synchronization is a result of a 3:2 mean motion resonance, meaning Pluto completes 2 orbits around the Sun for every 3 orbits completed by Neptune. Astrophysicists describe this interaction using terms like libration and orbital resonance. In this context, libration refers to the oscillation of Pluto's orbital parameters, ensuring its path remains stable over long timescales. This cosmic dance highlights the precision of gravitational interactions that govern celestial bodies in the solar system. Additionally, simulations of Pluto's orbit have shown that even slight deviations in its starting position or velocity could lead to vastly different orbital paths over millions of years. This sensitivity to initial conditions is a hallmark of chaos theory, emphasizing the unpredictable nature of celestial dynamics. Yet, despite this inherent unpredictability, Pluto's orbit has remained stable for billions of years, a testament to the delicate gravitational balance maintained by the solar system. The study of Pluto's orbital behavior also has far-reaching implications for understanding exoplanetary systems. Many extrasolar planets exhibit similarly chaotic and eccentric orbits due to gravitational interactions with neighboring planets or passing stars. By studying Pluto and its interactions with Neptune, scientists gain valuable insights into how planetary systems form, evolve, and stabilize over time. Looking beyond its orbit, Pluto itself continues to fascinate researchers with its geological and atmospheric features. NASA's New Horizons mission revealed a world of icy plains, towering mountains, and mysterious surface markings, reshaping our understanding of distant celestial bodies. Its largest moon, Charon, shares a unique gravitational relationship with Pluto, forming a binary system where both objects orbit a common center of mass located between them. The exploration of the Kuiper belt, where Pluto resides, has opened a new chapter in planetary science. This region, filled with icy bodies and dwarf planets, represents the remnants of the early solar system, offering a glimpse into its formation history. The ongoing study of Kuiper belt objects, including Pluto, may help answer fundamental questions about how planets and moons develop and evolve in diverse environments. As technology advances, astronomers will continue to monitor Pluto's orbit with unprecedented precision. Future space missions and telescopic observations will further refine our understanding of its orbital stability and interactions with neighboring celestial bodies. These studies will also inform our search for potentially habitable worlds in other star systems by applying the principles of orbital dynamics observed within our own solar system. In the grand cosmic narrative, Pluto's story is far from over. Its dynamic orbit, geological mysteries, and role as a gateway to the Kuiper belt ensure that it will remain a focal point of scientific discovery for years to come. As we peer deeper into the universe, Pluto serves as a reminder that even the smallest and most distant worlds can hold profound secrets about the nature of our solar system and the universe beyond.